Welcome to the DIY Honda Garage channel. The following presentation will cover the DTC P0122, which indicates a low voltage condition in the throttle position TP sensor A circuit of the Honda Civic models 2016 through 2021. The TP sensor plays a critical role in monitoring the position of the throttle plate, enabling precise engine control and fuel management. It sends a voltage signal to the powertrain control module, PCM, based on the throttle position, allowing for adjustments in air-fuel mixture and engine performance. If this signal drops below the threshold of 0.3 volts, as referenced in the diagnostic report, the PCM registers a P0122 code. This can adversely affect engine performance, fuel economy, and emissions. Thus, diagnosing and resolving the underlying issues promptly is essential to ensure the vehicle operates optimally. DTC P0122 indicates a low voltage in the TP sensor A circuit, which is vital for providing the PCM with accurate throttle position data. The throttle position sensor A is usually located on or within the throttle body. This sensor measures the position of the throttle plate and sends a voltage signal to the PCM that varies with the throttle angle. The PCM interprets this information to adjust fuel delivery and ignition timing, ensuring efficient engine performance. The signal from the TP sensor should typically fall within a specific range. When it falls below 0.3 volts, it triggers the P0122 code. Alongside the TP sensor, the PCM and throttle body are also impacted as the components interact to regulate the engine's performance. Understanding the roles of these parts is crucial for effectively diagnosing the error. Several issues can lead to the appearance of the P0122 code. Firstly, poor connections or loose terminals at the throttle body or the PCM can disrupt signal transmission, resulting in low voltage readings. Secondly, a short circuit in the THL1 wire could create a direct pathway for current that overrides proper signal flow. Additionally, a defective throttle body itself may not generate the correct signals or may have internal faults. An open circuit in the VCC3 wire would prevent proper voltage from reaching the TP sensor, further triggering the error code. Lastly, problems with the PCM could result in improper interpretation of the signals from the TP sensor. Identifying and resolving these underlying causes is crucial for rectifying the error. The manifestation of DTC P0122 can lead to several noticeable symptoms affecting the vehicle's performance. One common issue is poor engine performance, as the PCM cannot optimize fuel delivery due to erroneous throttle position data. The check engine light, CEL, will also illuminate on the dashboard, notifying the driver of the problem. Additionally, drivers may observe increased fuel consumption as the engine struggles to achieve optimal air-fuel mixtures. Rough idling and unstable acceleration can also occur, making the vehicle difficult to drive smoothly. These symptoms, if left unaddressed, can lead to more significant issues and should be monitored closely to ensure efficient vehicle operation. Begin troubleshooting DTC P0122 by first verifying the problem's presence. Turn the vehicle to the on mode without starting the engine to power the electrical systems. This allows the Honda Diagnostic System, HDS, to communicate with the vehicle's onboard computer. Next, clear the DTC using the HDS so you can assess if it reappears. Following this, check the parameters specific to the TP sensor A to confirm its operational status. You are particularly looking for the voltage reading. It should be above 0.3 volts under normal circumstances. If the reading is less than this threshold, it indicates a confirmed fault, and you can proceed to the next troubleshooting step. However, if the value is not decreased, this indicates an intermittent issue, which may require examining connections or terminations. In this second troubleshooting step, evaluate the overall diagnostic results by checking for both pending and confirmed DTCs using the HDS. Look for any codes indicating issues with the throttle position system, such as DTC P0222, which refers to throttle position sensor B. If DTC P0122 and P0222 appear together, it's likely that both sensors are experiencing issues, indicating a possible shared connection fault or a common issue impacting both sensors. If only P0122 appears, continue to the next step in the diagnostic process. This step is crucial as it allows you to map the extent of the problem and tailor your troubleshooting efforts to the specific issues identified. For the third troubleshooting step, begin by turning the vehicle to the off-lock mode. This is essential for safely performing diagnostic tests. Next, jump the SCS Service Check System line with the HDS, which will allow you to reset any ongoing faults and give the system a moment to stabilize. After waiting for more than 1 minute, disconnect both the PCM connector E and the throttle body 6P connector to isolate the circuit. This step is critical as it enables you to check the continuity in the wiring between the throttle body and the PCM. Once these connections are removed, you can proceed to test and evaluate the THL1 line in the subsequent checks. Next, check for continuity between the designated test points to evaluate the THL1 wire's integrity. With the throttle body 6P connector and PCM connector E disconnected, you will measure between the throttle body 6P connector number 6 and body ground. By conducting this continuity test in the off-lock mode, you can determine if there is a short in the THL1 wire. If continuity exists, it indicates a short circuit somewhere in the wiring. If no continuity is found, the THL1 wire is deemed okay, and you should investigate further through service documentation or consider replacing the PCM if necessary. This step is fundamental in isolating faults in the wiring that could be causing the P0122 code. In this step, you will determine the condition of the VCC3 line and assess the throttle body by measuring the voltage present. Start by disconnecting the throttle body 6P connector again and turning the vehicle to the on mode. At this point, measure the voltage between pins number 5 of the throttle body 6P connector and body ground. Ideally, you should see a reading close to about 5.0 volts if everything is functioning correctly. If you achieve this reading, you will need to replace the throttle body, as it indicates that the sensor is sending low voltage due to internal failure. If the reading is below this value, continue to the next step to examine other potential line faults. In this concluding troubleshooting step for DTC P0122, you will investigate the VCC3 wire for any interruptions or faults. First, turn the vehicle to the off-lock mode and again jump the SCS line. After detaching the PCM connector E, you will perform a continuity test by measuring between the throttle body 6P connector, pin number 5, and PCM connector E, pin number 75. In a healthy circuit, continuity should be established, indicating that there is an unobstructed connection in the VCC3 line. If continuity exists, check the service documentation for any authorized information related to the error. If continuity does not exist, it suggests a break in the wiring between the throttle body and the PCM, requiring repairs to ensure proper signal transmission. Once all necessary repairs and replacements have been made in response to the DTC P0122, it is imperative to verify the effectiveness of the solutions. utilize the HDS to recheck for any DTCs after completing the repairs. Ensure that there are no current or pending codes remaining in the system, confirming that the issue has been adequately addressed. Following this, conduct a thorough performance evaluation, checking all operational parameters of the throttle position sensor and the associated circuits. Confirm that the vehicle operates smoothly without symptoms associated with the initial DTC code. This final verification step is critical in ensuring that the problem is fully resolved and that the vehicle is performing optimally. Preventive maintenance plays an important role in avoiding issues related to DTC P0122 in the future. Performing regular inspections on the vehicle's throttle position sensor and associated wiring can help identify any potential issues proactively. Make it a habit to check the integrity of the connections and wiring associated with the throttle body and PCM. Additionally, keeping the throttle body clean from carbon buildup can help maintain sensor accuracy and performance. Implementing these maintenance practices consistently can mitigate risks associated with faulty sensors and ensure the longevity of both the throttle system and overall engine performance. Remember, prevention is always easier and more cost-effective than curing an issue after it has occurred. In conclusion, understanding the implications and effects of DTC P0122 is crucial for maintaining optimal vehicle performance in Honda Civics from 2016 to 2021. Employing a systematic approach to troubleshooting, as outlined, helps efficiently identify the root causes of low-voltage conditions within the throttle position sensor circuit. By carefully analyzing each step and understanding the components involved, technicians can accurately resolve the issue at hand. Furthermore, implementing preventive strategies will ensure the longevity of vehicle components and help avoid future occurrences of related DTCs. Proper education on these topics can empower vehicle owners and technicians alike to maintain their vehicles effectively. Please like and subscribe to the channel. See you next time.